Good morning, everyone. Welcome to the Q&A session 12 from the chapter of Work, Power and Energy. And the topic for this session is collision. So this session is a continuation of the session number 10 and 11. So in the previous two sessions, that is in the session number 10 and 11, we have studied about the elastic collision, and we have derived certain equations based on the fact that in the elastic collisions, the total linear momentum and the total energy are conserved, and the total kinetic energy before the collision and after the collision remains the same. So based on the last two sessions, I have taken one question which is written on this board. This question was asked in the IIT mains examination. So this question was asked in the IIT mains examination few years back. So now in this question, um, the question says that in a collinear collision, a particle with an initial speed v0 strikes a stationary particle of the same mass. If the final total kinetic energy is 50% greater than the original kinetic energy, the magnitude of the relative velocity between the two particles after the collision is. So there are four options here. So we have to find the correct one. So so in this question, the particles are having the same mass. So let us consider, first of all, let the mass of each particle be small m. First thing. Second point is that one particle which is moving with the speed of v0 strikes a stationary particle of the same mass. So one of the particle is having the velocity of v0, and the other and the velocity of the another particle of the same mass, or you can say the initial velocity of the another particle of the same mass is 0. Now, if the final total kinetic energy is 50% greater than the original kinetic energy, then we have to find the magnitude of the relative velocity between the two particles after the collision. So now initial velocity of one particle is given as v0. Now initial velocity of another particle which is stationary, this is equal to 0 because it is stationary. Let us say after the collision, let the velocity of the first particle be v1, and after the collision I am taking the velocity of the first particle as v1, and the velocity of the stationary particle as v2. So now in any collision, as I have just told you, the total linear momentum is always conserved, whether it is an elastic collision or whether it is an inelastic collision. What is the main difference between the elastic collision and the inelastic collision? In the inelastic collision, the total linear momentum and the total energy are conserved, whereas the total kinetic energy before the collision is not equal to the total kinetic energy of the is not equal to the total kinetic energy after the collision. Now, since here the final kinetic energy is 50% greater than the original kinetic energy, therefore this is an inelastic collision. So now from this statement I can write, first thing is that it implies that half m v1 square plus half m v2 square. Now this is the final means this is the total kinetic energy after the collision. Now if the final total kinetic energy is 50% greater, that is 50% greater means that is equal to 150 divided by 100 is greater than the initial total kinetic energy. As per this statement, the final total kinetic energy is 50% greater than the original kinetic energy. So now the original kinetic energy is equal to this. We can simply write this as half m v1 square plus half m v2 square. This is equal to this can be written as 3 by 2, and the total initial kinetic energy, that is the kinetic energy before the collision, this is equal to what? This will be equal to half m v naught square plus 0. 0 is the kinetic energy of the stationary particle, and before the collision this particle was the first. Here I have written that the particle which is striking the stationary one, I have taken it as the first particle, like this. So the velocity of this first particle was v naught before the collision. So the total kinetic energy before the collision will be equal to half m v naught square plus 0. So if from this statement, I can simply write that this 1 by 2, 1 by 2 and 1 by 2 will get cancelled out, and m and m will also get cancelled out. So what I will be getting is v1 square plus v2 square will be equal to 3 by 2 v naught square. So this is the first equation which I have got based on this condition, that is the total kinetic energy after the collision is 50% more than the total kinetic energy before the collision. So this is the first equation which I have got, and I will be now writing this equation on top of this board. That is v1 square plus v2 square is equal to 3 by 2 v naught square. Now, in any collision, as I have just told you, the total linear momentum is conserved. Therefore, the initial total linear momentum, that is the linear momentum before the collision, is equal to the total linear momentum after the collision. So, in that case, so it implies that now since total linear momentum is conserved, and this total linear momentum is conserved in the elastic collision as well as in the inelastic collision. So since total linear momentum is conserved, therefore m1 v naught plus m2 into 0, sorry, since the mass of both the particles is the same and we have taken it as m, therefore we will get m v naught square plus m into 0. This is equal to m v1 square plus, sorry, m v1 plus m v2. Mass into velocity is the momentum. So mass into velocity, this is the initial momentum of this of the particle which is colliding with the stationary particle. The initial momentum of the stationary particle is m into 0, which is equal to 0, and after the collision their velocities are v1 and v2 respectively. So since the total linear momentum is conserved in any collision, therefore m v naught plus m into 0 is equal to m v1 plus m v2. So here, from here I will be getting it that v naught is equal to v1 plus v2, because m and m will get cancelled out. This is equal to 0, so m will get cancelled out. Finally v naught will be equal to v1 plus v2. So this is the second equation which I am getting. Okay, now here we have to find the magnitude of the relative velocity between the two particles after the collision. That is, what we have to find is, we have to find v1 minus v2. We have to find the value of v1 minus v2, because v1 minus v2 is the relative velocity between the two particles after the collision. So from here we have got these two equations, and from these two equations we have to find the value of v1 minus v2. So from the equation number 1, from equation number 1, we get, what I can write this equation as, I can write this as v1 minus v2 whole square. If v1 minus v2 whole square will be equal to, this will be equal to v1 square plus v2 square minus 2 v1 v2. So since I am taking this v1 minus v2 as whole square, so here I will be writing as, because I have to get this equation. So therefore v1 minus v2 whole square plus 2 v1 v2, this will be equal to v1 square plus v2 square. Okay, because v1 minus v2 whole square is equal to v1 square plus v2 square minus 2 v1 v2. So I have written here as plus 2 v1 v2, so that I get this v1 square plus v2 square. So this is now equal to 3 by 2 v naught square. Now I have written this equation in this form because I have to find the relative velocity between the two particles after the collision, which is equal to v1 minus v2. So because of that, I have written this equation in this form, because I have to find the value of v1 minus v2. Now here the most important thing is that we have to find the value of v1 and v2. So if I, from equation number 2, from equation number 2, we can get, what I will do is, I will square this equation on both the sides. That is, v naught square will be equal to V1 plus V2 whole square, or we can say that V1 square plus V2 square plus 2V1 V2. Okay. What I have done is I have just squared this equation number 2 on both the sides. So I am getting this as V naught square is equal to V1 plus V2 whole square, and this is equal to V1 square plus V2 square plus 2V1 V2. Now V1 plus V2 is equal to 3 by 2 V naught square. Okay, and here so this can be written as, see here, from the equation number 1, V1 square plus V2 square is equal to 3 by 2 V naught square plus 2 V1 V2, and this is equal to V naught square. So what I have done is I have substituted the value of V1 square plus V2 square as 3 by 2 V naught square. So what I will be getting now? From this I will be able to find the value of V1 into V2. Or I will be able to find the value of 2V1 V2. So 2V1 V2 is equal to, I will take this term on the left hand side, so it will be equal to V naught square minus 3 by 2 V naught square. So this is equal to minus V naught square by 2. So so now as we have just just a few minutes back, we have I have written this equation number 1 as V1 minus V2 whole square plus 2 V1 V2, that is equal to 3 by 2 V naught square. I have written this equation number 1 in this form because I have to find the value of V1 minus V2. We have to find the value of we have to find the value of V1 minus V2. This is what we have to find. So that because we have to find the value of V1 minus V2, I have written this equation number 1 in this form. So because this is equal to what? V1 square plus V2 square minus 2V1 V2. So in order, because on the right hand side it is only V1 square plus V2 square. So I have written plus 2V1 V2 in order to get the same terms as given in the equation number 1. So this term, that is the terms on the left hand side of the equation, is equal, this is equal to V1 square plus V2 square, and this is equal to 3 by 2 V naught square. So now we have already find the value of 2V1 V2 as minus V. Let us say this is equation number 3. So from equation number 3 we get, what I will be doing is I will be substituting the value of 2V1 V2 as minus V naught square by 2. So what I will be getting is V1 minus V2 whole square minus V naught square by 2, which is equal to 3 by 2 V naught square. I have substituted the value of 2V1 V2 as minus V naught square divided by 2. So finally, what I am getting here is that V1 minus V2 whole square, this is equal to, I will take this term on the right hand side, so this will be equal to 3 by 2 V naught square plus 1 by 2 V naught square, and this is equal to 2 V naught square. If I add it, I will be getting 2 V naught square. So So in this way, so it implies that V1 minus V2, this is equal to under root 2 V0. Okay. So V1 minus V2 whole square, this is equal to 2 V0 square, or we can say that V1 minus V2 is equal to root 2 V0. So here our answer will be equal to, it will be the second option, that is B. B is the correct option of this answer. So in this question, the question was very easy. The only thing is that we have to use the concept we have to use the concept that the total linear momentum before the collision is equal to the total linear momentum after the collision in all types of collision. And this was an inelastic collision because here the kinetic energy was changing after the collision. So thank you very much for joining this session, and I hope you have understood the solution of it. And so in the next question I will be coming up with a different topic, and most probably it will be the I will be taking up the topic of inelastic collision. So till then, have a nice day. Bye.